Let's talk about writing a polynomial given the zeros. Now, normally we start with a polynomial and we find the zeros, but now we're going to start with the zeros and work our way backwards to create the polynomial. So the first one we're going to do is this one. Write a polynomial of least possible degree. That just means no extra zeros. These are the only zeros you're allowed to have, and let's just have them one time each. Having a leading coefficient of 1, so we're not going to have any extra multipliers, and integer coefficients, meaning if there's any radicals or imaginary numbers, we need to take care of those. In this question, I don't have any radicals, no imaginaries, so we don't even need to worry about that last piece. So what we're going to do is create a polynomial. I'll call it f of x. And that polynomial ends up being 0 when you plug in each of these numbers. So when I plug in a -5, I get 0. When I plug in a 4, I get 0. When I plug in a 2, I get 0. So each of these zeros is going to give me its own factor. When I plug in a -5, I get 0, which means that x plus 5 is a factor. So if I throw a -5 into that x spot, -5 plus 5 is 0. And then we would be multiplying 0 times this factor, and everything would zero out. So -5 is a 0 by creating that factor. Now my next one, +4, I have x, and I would want to subtract 4. If x is 4, then to get to 0, I need to subtract 4. And my last one, for +2 to be a 0, I would need x minus 2. Now from here, I'm going to simplify. I'm going to multiply everything out and write this in standard form. So I'll go ahead and multiply just the first two together. If you use FOIL, go ahead and use FOIL. I prefer just to distribute. So I'll distribute my x to x and -4. I get x squared minus 4x. Then I take my 5 and I distribute. I get 5x minus 20. I can then combine my like terms. And that's the product of the first two, but I still need to multiply by the third one. So I'm going to go ahead and multiply by x minus 2, and I start over with my distributing. I take my x squared and I distribute to the x and the -2. So I get x to the third minus 2x squared, and then I distribute my x. And lastly, my -20. I just combine my like terms from here. And this is my polynomial. Notice my leading coefficient is 1. When I look at the number that's in front of that highest degree, I have a 1. So my leading coefficient is 1. I have all integers, no fractions, no decimals, no radicals, nothing weird like that. And I have the least possible degree. I had 3 zeros and my degree is 3. So there's nothing extra here. So this would be the polynomial with the given zeros. Let's go ahead and do one more. Now in this one, we do have a radical that we're going to have to take care of. So when I go set up my polynomial, I need to take into consideration that when I multiply everything out, that radical is still going to be there. So I need something that cancels out my radical. And we call that the conjugate. And the conjugate is the same thing, it's just that the radical becomes the opposite. So I'm going to include a square root of 5 that is the opposite of this square root of 5. So I'll have a negative rad 5. So that's kind of a hidden 0. And the reason that that one's necessary is because we have to cancel out the square root of 5 somehow. And the only way to do that is with the conjugate. So even though they don't tell us that negative square root of 5 is a 0, it's implied because it has to cancel that square root of 5 that they did give us. So now when I go write out my polynomial, f of x, I have 3 zeros. My first one, x minus 4, then x minus the square root of 5, and then x minus a negative square root of 5. And I'll just make that x plus 5. So x plus square root 5. And now I go ahead and distribute. Word to the wise here, always distribute the two that have the radicals first or the conjugates first, because those are going to simplify super nicely really quickly. If you do these two first, it's going to be pretty nasty for a minute. So I'm going to go ahead and simplify these two. The whole point of that negative rad 5 was to cancel the positive rad 5. So this should simplify nicely. And if you remember, this is an example of the difference of squares. Difference of squares says this: if you have two perfect squares and you're subtracting them, then that factors into the bases added and subtracted. So we're going to do this or use this in reverse. So we know that we have the same two bases. I have x and square root 5, and then here I have x and square root 5, and we're adding them, and then we're subtracting them. So that means I have this, and what I'm going to end up with is this. If you want to FOIL, you can. If you see the shortcut, then let's just use the shortcut. It's going to save us a lot of time. So then what I really have here is a minus b times a plus b, where x is in the a spot and square root 5 is in the b spot. So then when I go multiply these two together, all I need to do is take my x and square it, take my square root of 5 and square it, and subtract them. So then I have x squared minus the radical and the square root cancel, and I've got 5. So those two factors multiplied together to give me just x squared minus 5. If you are not comfortable with that, then just distribute like we did the last one. Then I still have x minus 4 that I need to multiply. So I distribute. There's no fancy tricks for this one. I distribute. X times x squared is x to the third minus 5x. Move on to your 4 and distribute. And then combine like terms if you can. There are no like terms in this one, so I'm just going to write it in standard form from highest to lowest exponent. And that is my polynomial. Notice that the leading coefficient is 1. Notice that I have all integer coefficients, and I have the minimum number of zeros. My degree is 3, and that was how many zeros I had started with. So this is all you need. So there's a couple examples on how you would write a polynomial when you're given the zeros. I hope that helped. Thanks for watching, and I'll see you next time. Bye.